Guys, this is the homework for 10.5. Hope everyone's doing well. We got quite a few questions, and so here we go. The first one was number 9 on your homework, how to solve it. So here we go. First thing we need to do is realize that the angle we're looking for here is inside the circle. So we're going to have to use the angle is equal to 1/2 the sum based on my video. Now the problem is we want x. Problem is x does not line up with my arcs. It lines up with two arcs that we have no known for. So what we need to do is we need to realize that if this one is x, then the one we can calculate for is 180 minus x, because they are supplementary angles. It forms a straight line. So what I'm going to do is I'm going to write this out as an equation based on the 180 minus x, which I'll still solve for x at the end of it, with the 30 and the KL. So it says that our angle 180 minus x is equal to 1/2 the sum of the two arcs it intercepts. So it intercepts arc KL and intercepts the arc JM, because it does it on both sides of the angle, this angle and that angle, because they are vertical. So you know they're congruent. So we're going to say the sum. So 30 plus 2x minus 30. And again, pardon me for the writing because it's not great. So this ends up being 180 minus x equals 1/2. And if I combine 30 and negative 30, they'll go away. It's just 1/2 of 2x. So really, I'm left with, ooh, that was bad. I don't know what happened there. 180 minus x equals x. Well, then I'm just solving for x at this point. I get 180 equals 2x. X equals 90. And so we see that x is 90. And it ends up they both being right angles, which makes it very easy. And you can see that if you plug in 90, it ends up to work out. All right. So the next one we have is, I was asked about 16a and b. So we're going to start with a here. All right, and then I'll get over to b. B is basically something off of a. So what we have here is we have two circles. We have a big circle and we have a small circle. And I'm going to start with the big circle because the big circle is going to let me find something I need to help find the small circle. So the big circle, because we have this angle here for the big circle, we see that this angle is an inscribed angle. So that angle right there, this angle right in there, is an inscribed angle, which tells me it is 1/2 of the arc it intercepts. So it's 1/2 of this 110. So it's 1/2 of 110, which is 55. Now, that being said, knowing that this angle is 55, we can then use it to find x, because now that this angle, and I'll draw it in red now, intercepts two different arcs. It's a secant to the circle outside. So now my angle's on the outside of the circle. So this is combining the other one where my angle is 1/2 the difference, so that's subtraction, of the two arcs intercept. So it's x minus 40. And remember, when we're talking about which one to subtract, it's big arc minus small arc. Now, I'm not going to take 1/2 and distribute it. I'm going to actually multiply both sides by 2, or everything by 2, to help me do things. So the 2 is going to cancel out there. So I'm really much just doubling the 55. So I'm going to get 110 equals x minus 40. And so x equals 150 when you solve it. Now, basically, I'm going to do the same thing over on the right with c. But instead of writing, numbers, we're writing letters. So let's start with this. The first thing is, again, find that angle. And we know that it is 1/2 of whatever c is. And so whatever 1/2 of c is, right, is now equal to 1/2 b minus a. And since we're just solving for c here, all I'm going to do is multiply everything by 2 just to solve for c. So c equals b minus a. And the reason that works is because the 2 on each side times 1/2 basically cancel out. So c equals b minus a. So there is my answer. And if you think about it, guys, on the left-hand side, 110 is c, b is x, and a is 40. So it all works out the same way. All right, whoops. The next problem we had was number 17. I don't know why. All of a sudden we got an extra page. 17, and we're asked to find the measures of EF, FG, and GE. And what we see here is that we have this circle inscribed inside of a triangle, right? Basically saying, guys, that the triangle is tangent to the circle. All the sides are tangent at F, G, and E. And if you remember from my video, what I showed you was there was a little trick to this, that if you have a tangent, 2 tangents to a circle, that the angle inscribed is always supplementary to the arc it's next to. So, for example, here, 60 plus arc EF has to equal 180. So in this case, EF equals 120. And again, excuse the writing. And then I can do the same thing for R here. And I can say that angle R, 80, plus FG equals 180. So FG equals 100. I do not know why it doesn't want to make circles. And then I can do the same thing for P here and say that 40 plus EG equals 180. And so EG equals 140. And if you were to add up 120, 100, and 140, you would end up with 360, which makes a full circle as well. So the answers work out great. All right, and then the last 2 they gave me were 20 and 21, and I'm going to start with 20 here. Now, these were the challenge problems, so don't expect anything as hard as these on any test or quiz, but they do make you think about what's going on. So you have to use variables and everything. All right, so it says find measure of angle P if WZY is 200. So it's telling me that WZY right here, that is 200 degrees. Well, that doesn't help me because we're looking at a secant type of angle here. And so what I need to do is I need to go, okay, what am I looking at? Well, we see that WX and ZY are congruent. And if you remember back, that a theorem tells us that if the chords are congruent, then the angles they create or arcs they create are congruent as well. So I'm going to call WX X and then WZY is X as well because they're congruent. So I'm just going to call them both X. So by saying that X is equal to WX in terms of the arc, which is also equal to ZY in terms of that arc, what that allows me to now find is WZ and XY. Since WZ or WZY is 200, we also know that WXY has to be 160. And given that, we can now find WZ and XY respectively. Because think about it, guys. If ZY is X, that means that WZ has to be 200 minus X. And that also means that XY here has to be 160 minus X. And then what we're trying to find here is angle P. And so if we see about it with the secant, we know that angle P is equal to 1/2 the measure of arc WZ minus arc XY. Because again, it's on the outside, it's 1/2 the difference. So doing this, I can say angle P is 1/2. And now I'm just going to plug in WZ and XY respectively. In the first part, WZ is 200 minus X minus, and notice I'm putting in parentheses because I'm substituting, 160 minus X. So angle P equals 1/2. And now if I do this, this is 200 minus x, distributing the negative, minus 160 plus x. Well, if I combine like terms, this ends up being 1/2 of 40 because my x's will subtract out, which ends up being 20. And there's my answer. So all of a sudden, everything went away. All right, and the last one here, 21. Now, this one is really a challenge. It causes you to do multiple things at a time. And you have to really kind of think through this one. But again, not something you're going to see on a test or a quiz, but you just get it for see if you can do it. All right, so the first step we want to do, guys, and this is where it's really tricky, is that you actually want to find this angle right there or the other one right there. And the reason we do that is because we can actually find AF. Remember, the whole theory to this thing is even though we're trying to find AB and ED, right, is that you want to find as many of the arcs as possible, not necessarily the angles on the inside. But this is what's going to help us here. In that, if we can find CHD first, it's going to happen. Now, here's the great thing. Since we know that EHD, this angle right here is 115, then we know that CHD has to be 115 out of 180, which gives us 65, which we know is angle CHD. All right, so we know this here is 65. By doing that, it now allows us to find AF up here. Because 65 is an inside angle, it is equal to 1/2 the sum of the two arcs intercepts, so CD and EA. So we know angle CHD, ooh, that was bad. Let's try that again. Angle CHD is equal to 1/2 the sum of the two arcs intercepts. So it intercepts arc EA plus CD. So you see it intercepts of that arc. So this arc here and this arc here. Now I'm just going to substitute values I know. I know that CHD is 65 because we just found it, is equal to 1/2. EA, well, EF is 20, but we do not know EA, so I'm going to call it X. So it's 20. Actually, I'm just going to call it EA still. I'm sorry, FA. Or AF. Plus CD, which we now know is 85. So here we go. 65 equals 1/2. 105 plus AF. To solve for AF, right, I'm just going to double each side. So this is going to be 130 equals 105 plus AF. And so we see that AF equals 25. So now this up here is 25 degrees. So now this is going to help us here. So now we know that EA is 25. But we're still, so that right there can help us find some other things here. We know excuse me. We know that angle J right there, angle J up here in the top left, that's an outside angle, right? And it intercepts the arcs A and B and A and F. And since it's on the outside, we know that angle J is 1/2 the difference of arc AB, which is one we're looking for, minus arc AF. Well, guys, we know some of these values now. Now, here's where this comes in handy. We know that angle JAG is 60 degrees because it's told to us right there. We also know that here that at G, that's a right angle. So that makes a right triangle, which means, guys, angle J is equal to 90 minus 60. So it's 30. So now, look, we have 30 equals, I'm just plugging in values, equals 1/2 AB minus AF, which we just found here to be 25. So 30 equals 1/2 AB minus 25. So what I can do is, why don't I just multiply both sides by 2? And that gives me 60 equals AB minus 25. So that tells me AB here is 85. And that's one of my answers. So AB is now 85. So we got that. 85. I'm just writing it all over the place. Now we can solve for ED. And this is where it kind of gets a little bit tricky on everybody. I'm going to try to find this. I'll use pink here just so it stands out. So we need to find this right here, ED, right there. And we know, guys, and it's going to be a little hard to see, is that this angle right here, angle AGB or FGD or whatever, that's a 90-degree angle again, right? But it intercepts the arcs AB and FD. We can solve for this one now, because if you think about it, we have AB, we have the angle, right? We have FE. What we don't have is FD. So let me spell it out for you guys here. We're going to say angle AGB is equal to 1/2 the sum of arc AB plus JD. Now I'm going to just start plugging in values back. We know that AGB is 90 degrees, and that's equal to 1/2 the sum of the arcs. AB is 85 plus JD, which would be JE plus ED. That would be 20 plus ED. All right, so we get 90 equals 1/2, 105 plus ED. Again, I'm going to multiply both sides by 2. I get 180 equals 105 plus ED. So we see that ED here equals 75. And there are your answers. Again, if you have any more questions, please contact me and let me know.